like I mentioned, the last sessions were, I think, relatively heavier because they were very dense, and we had 1.5 hours talking about functions and 1 hour talking about objects, and then in the end I had to really show how objects really work and inheritance and prototyping, and how you can arrange JSON objects and to get yourself into a nice format of namespaces. But like I said, these are crucial, according to me, important parts, because this is how the modern JavaScript works, and there are billions of JavaScript frameworks right now, and some of them are based on other more advanced languages like TypeScript, but many of those, like jQuery that we're going to see now today, that actually are based on classic JavaScript, use all the stuff that we saw, and I think it's very important to know it. Just a sec. So our first part today, and the second part pretty much also, and maybe also most of the third part, we're going to talk about DOM, the document object model. As you probably know, the DOM represents our hierarchy of HTML elements, starting from the container of the HTML. So we have access to our window as an object in JavaScript. Inside the window, we have access to other properties of the window, like location, giving you information about your current address in the browser, or history, that gives you access to the history of the browser so you can navigate. And from that point on, from the document, we are going into the hierarchy of HTML elements. By the way, first recommendation for today, just a sec. I really recommend you to follow it and subscribe to it. Computerphile is one of the smartest channels talking about computer sciences and software. It's presented mostly by professors of software engineering, computer science, data analysis, all kinds of people, really smart, and they're talking about really important, nice things. The reason I just remember this channel is that it has 4 or 5 videos which are dedicated to HTML, and whether or not it's actually a computer language or not, there is like a discussion. So eventually it probably could be defined as a declarative language, even though it's not Turing complete. But if you want to watch those videos, I really, really, really recommend this channel. It's great for anyone who has interest and geeky enough to understand how software, and wants to understand concepts of how software really works by people who actually make it work. So HTML is our hierarchical structure of elements on the page, and we can traverse this tree going from object to object, and we can get properties, and that's what we do a lot when we work with JavaScript. Because it allows us to interact with the page, to make changes. 90% of what you need to do on a web page, on modern web page, is to make changes, to open stuff, to hide things, to show things, to flip tabs, to zoom on things, to show images, to hide images, to make animations. There's a lot of stuff that you're doing with HTML and with the JavaScript. I mean, that's mostly what people would use it for, to make a dynamic, interactive HTML page, and that's where we fall into what we used to call DHTML, dynamic HTML, which is a concept that doesn't really exist, but in the late 90s everybody was searching for people with proficiency with DHTML. So this is where we connect our JavaScript that can do very nice things like calculate things or make string manipulations, but in 90% of the cases, what you would really actually use it for is interacting with the web page itself, to make changes, to show things. So we have an API, the DOM API, and it allows us to interact with our page elements, add, remove, modify, change styling, change classes, add and remove attributes, read them, of course. You can read from them. You can interpret the structure of the page. So for those of you who are not yet, probably you are all, you're all, at least 3/4 of you are aware of what HTML actually looks like, right? So we have something like a tag here. That's an example. We have a paragraph tag, and then we have an attribute here, which in this case is a class attribute. Class gives us an option to style our object. So we have different classes. Like you can create your own classes for styling. You know what I'm talking about? I'll take it as a no. So in this case, we have an attribute. We can have many different attributes inside. See, the tag starts here and ends here. And we can get many, maybe I'll show it like this to be easier. Okay, so our tag starts here in the P, and this is the end of the tag, and this is the closing tag. Inside the tag, beside the name of the tag, in this case the name of the tag is P, which has to match with the ending tag here with /P. We have different properties that we can assign, and in this case the attribute is called class, which, like I explained, puts a class onto it. It could be actually nothing. It doesn't have to exist, this class, anywhere, but you can classify your object with different class names. You can have multiple classes on your object. And inside the object you have content. In this case, this is a paragraph, so it contains text, but it can contain, of course, other sub-elements, and you can build your HTML tree like this. So inside the paragraph you can put images, you can put text, you can put videos, you can put other containers like divs and stuff. Depends how you model your page, and that's the work of our front-end designer and developer. So all this, we can actually interact with all of those. We can interact with the HTML tags, which we also call elements. We can read their attributes, write their attributes, modify, go into their content, and dive into the sub-elements and pretty much manipulate them. For example, under the JavaScript environment, the browser gives us the document, which represents our HTML document, and under which we have a document element which represents the HTML tag itself. If it has some properties, you can read them from here. Or document.body will go to the body of your page, which is pretty mandatory to put in your page if you want something to be shown on screen. So much for HTML structure. Then we have different objects which represent specific elements. For example, HTML_li element, that's a class, JavaScript class that represents a list item, like this one. Or HTML audio element, which represents an audio tag, which is relatively new, by the way. Yeah, also some of the properties also have names, like HTML anchor element that has an href property or src property. We'll see some samples where we are manipulating styles, so each one of the styles has its own property name as well. But even if you don't know what properties those elements have, what attributes they have, you can still traverse through them, and you can read them with JavaScript, and you can discover them dynamically. So these are a few other common properties of objects. So we have inner HTML and outer HTML. So these will just return a string to us which represents the HTML itself. So if you have an element and you're holding an element with your JavaScript code, an object that represents the element in the page, if you get the outer HTML, you'll get the element itself and everything in it in a string. So you can just read it into a string. Inner HTML does the same thing, except that it leaves out the element itself. It takes only the internal part of it. So if you had a paragraph like I just showed you with text, so outer HTML will take the paragraph itself with the P and will just give you the HTML as a string. The outer HTML, the inner HTML will take it only what's internal. And then we have inner text and text content, these are two different ones depending on which browser you're working on. So inner text and text content return the string of the content of your tag. So if you have a paragraph like we just saw and it has different elements inside, actually inner text will return a textual representation of the text that actually gets rendered from this element without HTMLing it. So it's just a clean textual version of the content of the element. Let's see what we got. All right. So, what do we see? We have, in here, we have an image which has an ID. So again, we're talking a little bit about HTML. Image is, img is the image tag that contains an image. And ID is attribute that you can assign to every HTML element on your page, and that's a good way to actually access it, because as we'll see, if you want to interact with the HTML on your page, you have to actually find the element you want to interact with. So suppose you have a page and you have some image on it and you want to change the image, let's say when the user clicks something or when the user hovers, or just like that, you want to automatically change the image. So you can grab it by ID, and that's a very common way to get the element. And as we see here, what we are getting is the image we're putting into a variable, and we're calling the JavaScript DOM API document, and we call the method called getElementsBy, and we have to supply the ID. And suppose there is such an element, it will be returned here, and we can interact with it. Then we're setting the image.src property, which sets the source of the image, which means setting the image itself to this file, which is Telerik Ninja JPEG, and setting the Ninja image width to 400. Then we have some counter and some other variables, and showing that right now it is visible. And what we have here is function animation frame, which is declared here and immediately called. And what this function does, it's, just a minute. It checks if the Ninja image is visible. This is a Boolean that says if it's visible right now or not. If it's visible, it's changing the width to 0. Otherwise, it's changing the width to 400 and then switching to visibility parameter. So this parameter is Ninja visible is actually just flipping between true and false every time this function is called. And then we have another call here. The request animation frame. I want to show you how this works actually if we open it in the browser. So what happens is that it's flickering because this function gets recalled again and again. So every time we get here, right now the image is not visible, or it's supposed to be not visible. They've changed it already. Let's try again. Okay, so now the Ninja is visible, and now we're going to change its width to 0, set it to an invisible state, and we're calling the request animation frame method, which actually calls another. Actually, what we have here is a recursive call, and this method, if I'm not mistaken, is running the animation or running a function only if the current tab in the browser is active, and many websites actually rely on this function. So every time we go in, we hide and show the Ninja again and again. But it's too flickering, so I've changed a little bit the code here. I've added my own version. Let's see if I have to remove the other part or not. Yeah, that's better. So I'm pretty much changing the width. Instead of doing it right to 0, I'm changing the width multiple times. So every time we're entering this function again and again, we are changing the width in a few steps. I don't think I get more in detail into this right now, but I will supply more information about this functionality later. Okay, so again, in order to interact with DOM elements, what you need is to get the element itself first. So there are a few options to select the DOM elements into your variables so you can start interacting with them. We have the getElementsBy that we just saw. That means that the element should exist on the page, and it should have a specific ID by the string name given here. Hey. So, by the way, we're expecting a specific element with this ID. This should return only one element with this ID. If you have multiple elements, I think only the first one will get returned. An ID should basically be unique for your HTML elements. Then we have a query selector, which does the same thing here with a hashtag, because it uses selectors based on, similar to what we have on CSS, and similar to what we have on jQuery that we'll see later. So we can call document getElementsById or query selector, and here we can give any CSS-like query to find an element. So hashtag element name is actually the same as getting an element by the ID. And again, this should return a single element and put it into this variable. Then if we have a collection of elements on the page, we can get them by different methods as well. So we have the getElements multiple by tag name. So this will actually return all the controls in the page that have the li tag. So if you have 20 list items on the page, they will all get returned here, and you'll have a collection that you can go through. Elements by name does the same thing. So again, talking about basic HTML, an element would most probably would have, if you want to interact with it and it's unique, it would have a unique ID. It could have a name, elements by name, the name attribute, name equals something. So you could have multiple elements with the same name, and those could be grouped by grouped for some reason. So you can have multiple elements by the same names. And you can get the elements by their name or by their tag name, or by query selecting, again by doing query selector. And here you'll get similar again to what we have in jQuery that we'll see later, and similar to selectors of CSS. They use the same way. So here, for example, we'll get an element with the ID, because of this hashtag ID of main minus nav, and underneath it we're expecting to find list items somewhere as a descendant element with li. So that's the name of the tag, and that's the ID of the element, and this will return all of those list items into here, into this variable. There are also predefined collections of elements that you can use and directly consume without querying. So for example, document.links will get you all the links on the page, or document.forms will get you all the forms, web forms on the page. Basically with ASP.NET you are allowed to have only one web form on a page, but it's not HTML mandatory. If you're building a client side only, you can have multiple forms on the page. So the getElementsBy something, there are a few methods. The first, getElementsById. So again, an ID of an element should be expected to be unique by an element, and it will return you the element here You can get them by class name. Class name could be any element. So here we are getting any element on the page that uses this class. Class could be either a CSS class or just a class that means nothing, just so you can classify objects on your page. If it doesn't need to have corresponding CSS next to it, but it's useful if you want to style them, or if you want to classify them and collect them all at once. So this could return you all kinds of different elements on the page that use this class name. Tag name is a specific tag, specific HTML tag. So every element on the page which is the tag, HTML tag sidebar, will get returned here. And elements by name. So those are all the elements that have the name attribute assigned to with this specification. So let's see. I'm going to stop this. So here we have a simple form. Not a form, it's just a list of links. Okay, we have a body. Inside the body we have a header. Then we have a nav that has an ID. Nav is a semantic container which comes from HTML5 and has no meaning basically, except that it's a semantic meaning that we're building a navigation here, but of course doesn't have to be. It's just the HTML container. This heading, by the way, denotes that we're using HTML5 on the page. Then we have the head, the body, the header, the nav, the unordered list items, and we have 3 list items, and in each one we have an anchor link that links to nowhere, and they have those texts inside. So here, most of which this page will do, just scan those elements and put them on the page, put them in the log. So we will not basically see any effect unless we open our browser log. So first we're getting all the elements by ID, the element by ID, which is the main nav, which means we'll get this element here. And we're logging its inner HTML. So inner HTML, as I mentioned, goes and takes the HTML inside your element, but leaving out the element itself. If we wanted to include the element, we would have to use outer HTML. Then we're logging some separator lines, which is just repeating dashes. Then we're getting the UL, which is the unordered list object, which is this one. This will get all the elements which have UL on the page by tag name, and if we have multiple, we'll get basically what we'll get is a collection, regardless of how many we have. Even if we have just one, we'll have a collection of one. So we have to address the first one. We're taking the first by getting through this selector. We're returning the first and only one UL that we have. And again, we're printing out the inner HTML, which we're expecting to get this as a string printed out. Then we have all the elements by tag name, which means all these LIs, the list items here. We're going through them. We're getting them by tag name into a collection. And then we're running with a for loop, printing out their inner HTML. So in general, what we should get is each of those. And between each one of those actions, we are printing out a separator line, which is just the dashes. So let's see what's happening. So the page opened, and the JavaScript actually already executed. If we open the log, we should be able to see it in the console. And that's what we get. We got actually the inner HTML of each of those. First, the main nav that contains the ULs. It's been printed out just as an HTML string. Then we got the inner HTML of the unordered list, giving the LIs. And then on each of the LIs that we collected by tag name. Yeah, we collected each of the LIs by tag name, and we're printing their inner HTML like this. That's third. And Where's the last? We're getting the anchors, which are actually the links, all A's. I didn't understand what these A's mean. So it gets all the anchor links and printing their inner HTML. So that's how you could see that we could print out different chunks of the HTML of the page. And if we take a look at the debugger for a second, just to see what we're getting in every step. So you could see that, for example, now we're getting again the main nav by ID, and we got an element, and we got all kinds of properties that we can access and we can modify or read, which give us information about the DOM itself. So for example, it has child nodes. You can see that it has a UL as a child. There's a text which basically represents the empty space, I think. Let's see. No, that's the URI. I think that those texts are, yeah, they are either nothing or they contain, you see, the line break here too. And on one of those, we have the UL, which is the unordered list element, and underneath we have child nodes as well. So you can theoretically go through and really understand the structure. You can manipulate the structure, and you have already in your hand an object, a JavaScript object that lets you interact with the DOM elements that you just read. Now, the query selector the query selector and the query selector all. These are two powerful selectors that are used, like I mentioned, in other implementations. Of course, not supported by anything below Internet Explorer 8, but it gives you a powerful selection of elements by complete hierarchy. So, for example, by ID, just put a hashtag. If you want all the LIs under this ID, put a hashtag and then give the hierarchy of tags. So it would either return a specific element or a collection of elements, but it depends on which one you're using. And if you know anything about CSS and how CSS selectors work, this is pretty much the same. So it's very useful. Okay, the same, almost, yeah, same page, the navigation with the links. So here we are again using the document query selector to get the main navigation item, which is by ID. And here we got the nav items, which are by ID. And then we're going to the UL and all the descendants, which are LI and A. So actually what we are getting is, I think, I'm not sure if this would actually go traverse to the A's, or we'll stop here because of this notation of brackets. But let's see if I'm right, or if I remember it correctly. So again, maybe the best way to see what's happening is a debug. So here's our main navigation item by ID, and here's the nav items. So it did go all the way in. So we got from this element to the UL element, and underneath it the LI and anchors directly. And that's what we got printed out. I just wonder if I remember. what will happen now? The same. Okay. Okay. So this there is something weird about this notation with the greater than that we had before, because I think that what I did when I deleted them was pretty much the same thing as expected, and I think that when you are denoting it like this, what you're actually saying is give me the UL that has a child which is this, that has a child which is that. So in that case, if you want to access the A's, the actual element, this one, you would not need those. But I'm pretty sure I'm right. Mm-hmm. It doesn't work with XPath in this case. It's not an XPath selector. It goes.
Some kind to select it's not specifying the whole path, but
you don't need the whole path. I think that if you do something like that, let's see if this will also work. Yeah. So it's descendant. It's not direct child. Okay. So far we saw that you can call the methods through the document element. So the document that the browser gives you access to all these functions, but also the elements themselves that we saw that you get returned from these calls. For example, here we're calling calling to get an object with the ID wrapper, and we get it here. And then we can also call wrapper getElementsBy tag, and then we will get elements inside this one. So that's also one way to traverse. You can find an element and continue from there. So you don't have to traverse the whole document again, or you don't have to build complicated queries like this. You can just get an element and continue inwards from it. So that's the power here. So at least to get sub-elements by their ID and the other basic functions you can do. So pretty much the same thing again, the same page with the same effect. The only difference here is that we're not calling document query, but we're calling the main nav query, and we're getting sub-elements. So we're starting from this point, this one, and this is now our parent element, and from here we're doing a selection of UL, LI, and A. And again, I think that this is redundant, or very subtle difference from what I think it should be. And again, we'll print out to the console. So yeah, same effect. By the way, you know that if you have links here, that if you want to know where this thing came from, you can see the code which logged this console. Okay, so you can also get collections. We've seen also some of the query methods that give you collections of elements, not just a specific single one. So you can query elements by their tag name, so you can have multiple elements with the same tag on the page, of course. You can have multiple objects with the same name. ID is expected to be unique, but name is not expected to be unique. Class name, because you can classify anything on the page with the class attribute. And select all, which just gives you a free selector, just like we just saw, so you can select whichever elements. And what you get in return is a node list, which is a collection of nodes, basically a collection of those objects that you can interact with again. And we will see those. Actually, we're going to talk about DOM now, and our next segment is also going to be talking about DOM, and the next is going to be jQuery, which also very tightly coupled to all this. So NodeLists are objects. They behave a bit like arrays. They have length and they have indexers, so you can go through them with loops like we saw, but I think that not in every case for in would work properly. So they don't behave 100% well as arrays. So if you need to actually go through a collection of NodeLists that you got from one of these method calls, the best would be to do it with a for loop like we did earlier. So let's see. Okay, so what do we got now? We have a collection of divs with some text in each one. Now we're getting all the div elements by getting all the divs. And okay, so here we're checking whether they are instantiating this keyword, whether this object is an instance of JavaScript array. Basically, if the type of this is the type of array, and also then we're checking whether it's an HTML collection, which this should be actually the true one. And then we're running through them with an indexer with a for in loop, but let's see what we got.
So the HTML collection is not an array.
It's not. So we got false for the first call. Just a second. So this is the collection that we got back. You can see also that it's indicated by a prototype of HTML collection. So it is an object basically that's populated by the DOM. So these two logs actually should say that this should be a false and this should be a true. And now when we're going with a for in, I'm not sure this index would work or why. So I think that in some case you should get here some, unlike an array that would give you an healthy indexer that you can always rely on, I think that here you might have some problems with this. You could see that what we got is the 4 elements that we ran through with the for in, plus 2 more properties that are assigned to this object. But I'm not sure this is a reliable way of going through. Besides, plus you got here 3 more properties that are not part of the array collection. So otherwise, they are like an array but they are, I think that this could be problematic in some scenarios, that we are relying on the fact that this would be and behave like an queryable array. About the NodeLists, there are two scenarios where you get a list of elements on the page, a collection of elements on the page. One of them would be a live collection, and the other would be a static collection. So if you're talking about static collection like the one that returns from the query select all, what you get is a collection of elements that stay static in your variable and does not change when the page gets updated. On the other hand, if you do the getElementsBy, those get dynamically changed when you apply changes to the page. Yeah, I'll not talk about performance right now. So okay, so here we have a button on top of those divs that we have a method to handle the click on it, which is this one. And we'll see on the next section about manipulating the DOM and adding and removing elements. But here we're actually appending another clone child of the div element that we have collected from here, we have created here. We're creating a copy of it and appending it to the body, to the child, to the document. And here we can see that we have two collections. One of them is the divs that we got with getElementsBy tag name, and the one which is the QDivs, which we got here, which we got from the query selector. So every time we add a div to the collection, we're actually not taking those again. We're just using the variables that were defined outside of the function globally, but we can see how they evolve in each of those every time. We'll see which one of those grows. So actually, if we see it, okay, so we're starting with 4 elements. So each of those, when we're collecting both of those with the query selectors here, should have a length of 4. But then when we are incrementing this collection, we're adding new elements to the page, new div elements to the page. We're actually changing those selections. But let's see. So when I add, you can see already that the getElementsBy tag name got up to date to 5 elements right now, but the query selector remained with what it selected initially, so it's not dynamically alive. So that's an important difference, and if I keep adding, you'll see that those keep growing. So have a collection like this. When you get getElementsBy tag name, you can actually interact with the page also when it changes. So whenever you are looking at this collection, you don't have to query it again. It will get up to date accordingly.